So factoring polynomials. So to factor a polynomial or a number, to factor anything, is just to write it as a product. So if we had like 2 times 3, if you were given that problem, you would say that's equal to 6. So going from here to here is simplifying. But there are some times when it is convenient to have this in factored form, so to write it as 2 times 3 instead of as 6. So going from here to here is factoring. You want to be really careful that you understand the difference because sometimes it'll ask for your answer in simplified form. And for this chapter, sometimes it'll ask for your answer in factored form. But really, factoring is only something we do if we have a reason to do it. So we're going to factor to simplify fractions. We're going to factor to find least common denominators. We're going to factor to solve certain equations. But it's not the same as simplifying in the sense that every time you get an answer that's a polynomial, you should factor it to get your final answer. It's really just something that we do for a specific purpose because it helps us accomplish other things. That can get a little confusing in these couple sections because we're just factoring for factoring's sake, just to practice how to do it. So be careful to just read the instructions if your answer should be in simplified form or if you're factoring. In terms of polynomials, we can look at the same thing. So yesterday we did problems like this. And given that problem, if we were to simplify, we would say that's equal to 2x squared minus 7x minus 15. Again, going from here to here, doing that multiplication is simplifying. And our goal today is to start with something on the like what's on the right side and rewrite it in factored form like what's on the left side. So this is factoring. So we're going to start with the most basic factoring, which is factoring out a GCF, the greatest common factor. So GCF is the greatest common factor. Which is the largest factor that a group of polynomials have in common. Because we're talking about monomials and not just numbers, we sort of have to think about what we mean by largest. So numerically, we want the biggest coefficient possible. And then in terms of the variable factor, we want it to have the highest degree possible. So when we factor out a GCF, what we're really doing is just the distributive property in reverse. So we know the distributive property. If I was going to simplify 4x times x plus 9, I would distribute the 4x, which would give me 4x squared plus 36x. If we are given 4x squared plus 36x and asked to factor it, we're just doing that exact thing in reverse. And we can pretend for a second that we don't know what the answer is going to be. And look at 4x squared and 36x. So you want to look at the numbers first, and we see that they have a common factor of 4. So my GCF is going to contain a coefficient of 4. And then looking at the variables, if I have x squared, it contains 2 factors of x, and then x contains 1 factor of x, so they have 1 factor of x in common. And that variable factor is always just going to be the smallest exponent. So if I had like x to the 12th, x to the 9th, and x to the 7th, then the GCF would contain 7 factors of x. Because if I have 12 factors or 9 factors of x, then I have at least 7. So they have that 7 factors in common. So taking out that 4x, we think about what you would have to multiply 4x by to get what you started with. So if I take a factor of 4x out of 4x squared, I'm left with a single factor of x, because if I were to multiply 4x by x, I would get that 4x squared. There's addition between my two terms, and then taking a factor of 4 out of 36 leaves me with a factor of 9. And then I took that single factor of x out, and so I don't have any factors of x. And we see we ended up with exactly what we started with in the previous problem, which is good because they're the same. So we're literally undistributing. So we identify what they have in common, and then we pull it out of each factor, or each term, and then what's in the parentheses is like our leftovers, like what we're left with in each term once we take that factor out. So let's do a couple more. We're going to factor, let's do 12x squared times y minus 20 x to the third times y plus 4xy. What's my GCF here? 4xy, good. So I see that 12, 20, and 4 have a common factor of 4. Everybody has at least 1 factor of x, and everybody has at least 1 factor of y. And when you think about what you're left with, you can think like in terms of the coefficient, the factors of x and the factors of y kind of separately, so you don't have to do it all at once. So if I take a factor of 4 out of 12, I'm left with a factor of 3. Taking 1 factor of x out leaves me with a single factor of x left. And then I took that factor of y out, so I don't have any more factors of y. Then minus 5. I'm left with 2 factors of x and no factors of y. And then on that last term, it's like, oh, well, I took 4xy out, so I'm not left with anything. But if we stop there and just say there's nothing there, imagine distributing that 4xy. All you would get if you distributed is this part of it, right? That last term would disappear. So we need a factor of 1 sort of as a placeholder, because that's what you would multiply 4xy by to get that 4xy. In general, the number of terms that the original polynomial has to be the same as the number of terms that are in the parentheses when you factor out the GCF. When you factor out a GCF, you can never lose or gain terms in the polynomial. So that can help you remember those placeholders of 1, because we have 3 terms in our original polynomial, so in the parentheses I have to have 3 terms as well. Questions so far? Okay, let's talk about signs a little bit. So I'm going to factor negative 35 x to the 4th plus 20. So in general, when you factor out the GCF, the sign of your GCF is always going to be the same as the sign of the first term in your original polynomial. So the idea is that in the parentheses, we want the first term in that polynomial to always be positive, which means if we start with a polynomial that has a negative first term, we're going to take that negative out with our GCF. So here, my GCF, so 35 and 20 have a common factor of 5. But instead of a 5, we're going to take a negative 5 out. And so that gives me 7x to the 4th in my first term. And then I have a positive 20. Taking a factor of negative 5 out gives me a negative 4. And if you find yourself getting mixed up with the signs, just always distribute when you're done. Even if you're just doing it in your head, think about, oh, negative 5 times negative 4 is a positive 20. If you put a positive 4 there, negative 5 times positive 4 would be a negative 20, which isn't what you started with. Yes? You could. However, we always want the first term to be positive. And so if our first term is negative, we take a negative out. And just doing that by convention serves a couple of purposes. When we factor by grouping, it allows us to get common binomial factors by getting the signs right in both. And then also, all the methods that we have for factoring further work a lot nicer if that first term is positive. The signs just work out a little bit better. Everybody good with this? Should we do more examples, or you think we're good? I think we're good. Okay, so on a separate sheet of paper, we're going to start our general factoring strategy. And this is the strategy we're going to use to factor any polynomial. So you want it on a separate sheet of paper just so we can continue to add to it and you have it all in one place. So first things first, we always want to start with a polynomial in descending order. Descending order just means that the terms are ordered in such a way that you have the term with the highest degree first, second highest degree second, etc. So if we look back at what we've done, this is in descending order because we have degree 4 and then degree 0. And this is in descending order because we have degree 2 and then degree 1. So it's descending order of the degree of the terms. And so if it's not already in descending order, we'll always start by putting it in that order before we even start with our factoring strategy. So then our first step is going to be to factor out the GCF. And sometimes there won't be a GCF higher than 1 to factor out, but the first term will be negative. So, like I said, we always want the first term to be positive. So if necessary, we're going to factor out just a factor of -1 to make our first term positive. And I'll show you what I mean. So if I was given like -x² plus 3x minus 4, I see that x², 3x, and 4 don't have any common factors other than 1. Like everything has a common factor of 1. But there's no other GCF that I can pull out. However, I notice that the first term is negative, and I want it to be positive, and so that's where you just can take out a factor of -1. And the only thing that does is just change the sign of each of your terms. So it gives us x² minus 3x plus 4. So if we need to, we'll do that just to get it in the form that we want it to be in. So when we factor out GCFs, the GCF can be anything. Like it doesn't just have to be a monomial. So if I have, let's look at this guy, x² times, let's call it a, plus 2 times a. How many terms does that polynomial have? So remember that terms are separated by addition and subtraction. So there's 2, right? There's multiplication within terms, but between terms is just addition, subtraction. So I have 1 term here and 1 term here. Remember yesterday we talked about how there's different ways of writing multiplication, so these aren't always going to look the same. Here, like I used a dot, whereas in the previous problems we just smushed things together. What factor do those 2 terms have in common? Yeah, they have a common factor of a, right? So I'm going to factor the a out, and I get a times x² plus 2. Now that a can be anything, like I said. It doesn't have to be just a number or an x or a monomial. It could in fact be a whole polynomial. So if I wanted to factor this polynomial, x² times x plus 4 plus 2 times x plus 4. How many terms does that polynomial have? It still has 2. So addition and subtraction that occur inside parentheses don't count as separating terms because they're part of the individual factors in the term. So when you think about how many terms you have, you want to look for addition and subtraction that is outside parentheses. So here we have 1 term here and 1 term here, and they're separated by addition. And do those 2 terms have a common factor? X plus 4, right? So when we look at x plus 4, one thing to remember is that x plus 4 doesn't have a factor of x or a factor of 4. It's not divisible by either because that's addition in between the x and the 4. If it was 4x, it would have a factor of 4 and a factor of x. But in this case, x plus 4 is a single factor all by itself. It's grouped by those parentheses. So I can factor x plus 4 out just like I factored the a out above. So our common factor comes out front. And then in parentheses, if I take a factor of x plus 4 out of the first term, I'm left with x squared. There's addition between my terms. And if we take a factor of x plus 4 out of the second term, we're left with 2. So this process here is going to be the basis for what we call factoring by grouping, which is how we're going to factor polynomials that have 4 terms. So if you go back to your strategy, the second step is going to be to ask yourself how many terms there are. And we're going to look at 3 cases. The first one is if we have 4 terms, in which case we're going to factor by grouping. I'll let you finish writing and then I'll show you what that is. Everybody got it? Ryan, you good? So let's look at eight x to the third plus 2x squared plus 12x plus 3. So if I think about my factoring strategy, the first thing I ask myself is this in descending order? And it is, right? My degrees go 3, 2, 1, 0. And then the second thing I want to think about is, can I factor out a GCF? So is there a GCF I can factor out of this whole polynomial? There's not, right? 8, 2, 12, and 3 don't have any common factors. And then they don't all have a factor of x, so I can't take any variables out either. So then I ask myself, how many terms are there? There are 4 terms here. And so I'm going to factor by grouping. The way we start this is by splitting our 4 terms into 2 groups of 2 terms each. The split always occurs after the second term before that addition or subtraction. And notice I just use like a dotted line to separate them. If you need a visual separation, please use like a line or a dotted line. You don't want to use parentheses. People get themselves in trouble with parentheses because as soon as I put parentheses like so, I have changed that to multiplication instead of addition between my groups. And so we've completely changed the problem and the meaning of what we're writing. So we'll just use that line because it doesn't have any mathematical meaning, and so there's no risk of it changing what that expression is. So now that we've split it, we're going to take the GCF out of each group individually. So we look at the first 2 terms, and what's the GCF of the first 2 terms only? 2x squared, good. So we'll factor a 2x squared out. That leaves me with 4x plus 1. And then the operation between my 2 groups is addition. That always stays the same. So if you have subtraction there, you'll bring down the subtraction. If you have addition there, you'll bring down the addition. That sign will never change. And then what's the GCF of my second 2? 3, right? Good. And that leaves me with 4x plus 1. And so now we're right back in the situation we were in that previous example, right? We have 2 terms. Here's 1 term. Here's another term. And they have a common binomial factor of 4x plus 1. So they both have a factor of 4x plus 1. So we will bring 4x plus 1 out Taking a factor of 4x plus 1 out of the first term leaves me with 2x squared. I have addition between my terms. And taking a factor of 4x plus 1 out of the second term leaves me with 3. If you get tripped up about what that second polynomial should be, you can literally think of it as like if I took 4x plus 1 out of this and I took 4x plus 1 out of that, what you're left with. So 2x squared plus 3. So you can even like cover up those factors to see that if you find yourself having trouble with it. Any questions about the process? Okay, let's do a couple more. So let's factor 4x to the fourth minus 15x plus 20x to the third minus 3x squared. What's my first step? Yeah, to put it in descending order. So we have 4x to the fourth plus 20x to the third minus 3x squared minus 15x. What next?
Divide into two. What's that?
Step 1. Yeah, we're going to factor out the GCF. Factoring out the GCF is the most commonly forgotten step. In fact, most of the time when somebody emails me or calls me or texts me or comes running into my office and it's like, I can't make this work, and I say, did you factor out the GCF? All of a sudden it works. Like that's usually what people are forgetting if something's not working out. I even have a GCF stamp for your homework. Which leaves us with 4x to the fourth plus, no it doesn't, just kidding, 4x to the third plus 20x squared minus 3x minus 15. Now from here, we're focusing just on the polynomial in the parentheses. That x is going to come along for the ride. It plays no part in what we're about to do. So now we say how many terms, and when we're just looking at what's in the parentheses. So we have 4 terms, which means we're going to factor that by grouping. So we'll make the split right here. And the x is just coming along for the ride. I like to use just big brackets so I can completely separate everything I'm doing from that factor of x. So looking at my first 2 terms, I see that I have a common factor of 4x squared. Which leaves me with x plus 5. In between my groups is that subtraction. So that comes with me. And then I see that 3 and 15 have a common factor of 3. But because that's subtraction, when I take that 3 out, I'm really taking a negative 3 out. Right? Just like if you were distributing, you would distribute a negative 3 here. And so when I take a negative 3 out of that negative 3x, that leaves me with a positive x. When I take a negative 3 out of the negative 15, that leaves me with a positive 5. So again, that's a place you just want to be careful. Think about actually distributing the negative 3, and you can see how you get the negative 3x minus 15. Whereas if we put a minus 5 there, that would give us a positive 15, and that's not what we started with. So now I have that common factor of x plus 5. So we have our x that's just coming with us. We have our common factor of x plus 5. And then taking x plus 5 out of the first term leaves me with 4x squared. There's subtraction between my terms. And taking an x plus 5 out of the second term gives me that 3. I don't need the brackets anymore because the only operation now is multiplication, right? Outside the parentheses. So this is done, it's in factored form because it's all multiplication. Whereas in the brackets there, I still had subtraction between my groups. And so that's why I needed that to be grouped. You could use parentheses also, but I find that there's already a lot of parentheses going on. Yes?
Do you not take that x out in the beginning? Is it considered wrong?
It is considered incomplete.
Okay.
So any factoring you do, as long as it multiplies to the original, is correct in the sense that it's true. But if you think about numbers, if I asked you to write the prime factorization of 24 and you wrote it as 12 times 2, that's true. 24 is equal to 12 times 2, but it's not the prime factorization because 12 isn't a prime number. So the same is true with polynomials. You want to factor it down to the point where none of the factors can be factored anymore. It is true that if you don't take the GCF out at the beginning, you can take it out at the end. I find that typically people forget to do that if they go through all the work to get to that point. It also, if there's a numerical GCF, it makes the numbers a lot smaller. So factoring after taking the GCF out often gives you nicer numbers to work with. Okay, let's give you guys one to try. So let's factor two x to the fourth minus 4x to the third minus 10x plus 20. Be sure you go through your whole list, descending order, GCF. How many terms? 3 terms. We're just going to start talking about 3 terms, and we'll do much more of it tomorrow, but I want to at least get our general strategy down. So we're going to use what we call the AC method. To rewrite with 4 terms. Because once we rewrite it with 4 terms, we can then factor by grouping. So this is kind of the basis for our whole strategy, is that we want to factor everything by grouping. So if it has 3 terms, we'll write it with 4 terms. If it has 2 terms, we'll write it with 3 terms, so we can write it with 4 terms. And then we can factor everything by grouping. So let's look at how we multiply to get 3-term polynomials first. So if I was multiplying 2x plus 3 times x plus 5, we would get 2x squared plus 10x plus 3x plus 15. And then we'd combine like terms to get 2x squared plus 13x plus 15. So if we start with a trinomial, so we're starting with 2x squared plus 13x plus 15. Sort of in the back of my mind, I'm thinking, well, that 13x really came from combining two like terms, right? And so our goal is going to be to split that 13x up in such a way that we can factor by grouping. Now there's an infinite number of ways we could write 13x, right? We could write as 2x plus 11x, we could write it as 9x plus 4x, we could write it as negative 20x plus 33x. Like, there's an infinite number of ways we could do it. There's only one that will work, though. And so the method that we use, like I said, is called the AC method. So we're starting with a polynomial of the form ax squared plus bx plus c. And what we want to do is find two numbers with a product of AC. So product is multiplication, so that means the two numbers multiply to get the same thing that you get when you multiply. I'm sorry. It's cutting off. I didn't realize it cut it off. Should be ax squared plus bx plus c. I'll stop going all the way to the edge. So a product of AC. AC is the coefficient of the first term times the coefficient of the last term, right? Notice there's no variables involved. We're just using the coefficients here. And we want a sum of B, which is the coefficient of the middle term. So in our case here, A times C is equal to, well, A is 2. Sorry?
Oh, I was just saying.
No, yeah, tell me.
So is it 30x squared, or is it just 30?
So it's just 30. So we're just working with the coefficient. So 2 times 15 gives me 30. And then B is just the coefficient of the middle term, which in this case is 13. So the quickest way to do this, because there's more ways to add to a certain number than to multiply to a certain number, so we're going to look at the product first. We're just going to make a list of all pairs of numbers that multiply to 30. So there's 1 and 30, 2 and 15, 3 and 10, 5 and 6. And those are the only pairs of numbers that multiply to 30. So now I just want to see if any of those pairs add to 13. In this case, 3 and 10 add to 13, so those are going to be my two numbers. If you make your list of numbers that multiply to AC and none of them add to B, then the polynomial is prime. It can't be factored. Yes?
Wait, why did we do 15 times 2? Or to get 30, how did we get the 30 again?
2 times 15. So A is 2 and C is 15. So A times C is going to be 30. So I've got my two numbers, and now I'm going to rewrite that middle term using those as the coefficients of two separate terms. So the first term stays the same. Instead of 13x for my second term, I'm going to write 3x plus 10x. So that's where I use the two numbers I just found. And then my last term stays the same. So we didn't really do anything to our polynomial here. We just split up that middle term into two terms using the two numbers that we found. And now we have four terms, so we can factor by grouping. We will split it. Factor out an x. plus. We have a common factor of 5. So we get 2x plus 3 times x plus 5. And the order that you put that the 3x and the 10x in doesn't matter. If I'd written 10x plus 3x, we would get exactly the same answer in the end. So the order of those two numbers is totally up to you. So tonight, most of your homework is going to be factoring out the GCF and factoring by grouping, but you have a few of these 3-term polynomials. What I want you to focus on is how to figure out what the signs of your two numbers should be. So if they should both be positive, if they should both be negative, if you should have one of each. And then tomorrow when we come back together, we'll talk about those signs a little bit more. You have both my math lab and written work out of the book.
Oh.